दोस्तों जय हिंद जय भारत नमस्कार. In continuation with our discussion, today I have selected one of the most important topic when you are commissioning the VSD. One of the most important parameter is at what frequency we need to switch IGBT. That switching frequency, what we call as a switching frequency, carrier frequency. And many times this particular parameter is been factory set, and if we play with this particular parameter during the commissioning, what will happen? What are the advantage of and disadvantage of keeping IGBT switching frequency at the higher rate, higher level or a moderate level? We can set the IGBT switching frequency from the VSD controller in 2 kilohertz, 4 kilohertz, 6 kilohertz, 8 kilohertz, and we can go up to the 16 kilohertz nowadays. But what is the moderate setting of this particular IGBT switching, and what are the advantage and disadvantage? Today we will discuss in this tutorial. This is purely an educational video. There is no relation with any company, any VSD brand. So let me try to. You can see here from the left side, the VSD is running and sinusoidal PWM technique is being used for the generation of the firing signal for the IGBT. Now you can see here my inverter is running and running the motor at the load. If I keep the switching frequency at a lower end, you can see here how the switching frequency is. This is the carrier frequency, what we have seen, what we have uh, mentioned on the upper side. And suppose this is for an example, it's a 2 kilohertz. It's a extremely lower switching frequency. And with the S type of PWM, that means sinusoidal PWM technique, whenever the sine wave is crossing this carrier frequency, the IGBT pulse are to be generated for the getting of the IGBT. You can see here in this particular case, whenever the sine is crossing this particular carrier frequency, for the upper limit, you can see here this black bars are a getting signal of an IGBT. And once you switch down and switch off the IGBT with such a lower frequency, you can see here you will find a fantastic sinusoidal wave at the output. But if I change this switching frequency, if I change the carrier frequency, the black triangle frequency, now I have changed. If you see here, now in bottom line I have changed, make it double. You can see here, if you change this, the particular, you can see now you are going nearer to the sine wave. You will find a multiple switching signals in a same triangle with the same sine wave. You can see here, with by increasing the switching frequency, the getting signal is been now with such a fast action, so that you will find nearer to the sine wave. That upper picture showing the lower switching frequency, low bottom one is called a higher switching frequency. For an example, 4 kilohertz, 8 kilohertz. Now what will happen if I switching off and switching on at a lower? If I keep this my frequency, this is the getting signal for the IGBT. What I have seen in the, what I have mentioned in the last slide, you can see here the getting signal, the lower switching frequency, the IGBT will switch on and switch off at a lower frequency, at a lower switching frequency. Let me tell for an example, 2 kilohertz. The sine wave you can see here, this sine wave is a disturbed sine wave, and then the motor is supposed to receive an sine wave nearer to the sine wave. You can see this is the problem with the lower switching frequency. But to get a good sine wave, you increase the switching frequency. Now I have increased the switching frequency of the IGBT, and once you switch on and switch off the IGBT at the higher switching frequency, you can see this is the higher switching frequency, the sine wave, you will get a better sine wave. But this is how, for an user, this is the problematic. At what switching frequency we are supposed to switch on and switch off the IGBT? Indirect way, what should the carrier frequency setting in by VSD? So let me try to explain both advantage and disadvantage in parallel. Moderate switching frequency of IGBT is a good action. The moderate one, nowadays we are supposed to set this particular switching frequency, carrier frequency, 4 kilohertz has been declared as a moderate switching frequency. If you switch on and switch off the IGBT, sorry, if you switch on and switch off the IGBT at a more at a at the first requirement is IGBT must have lower switching losses. If you switch on and switch off the IGBT at a higher switching frequency, it will generate the heat. So IGBT, the first requirement, IGBT must have lower switching losses. The second one is this high switching frequency have a pure sine wave, nearer to the pure sine wave. So this is the advantage. Lower switching frequency will generate the less heat, If you keep the higher switching frequency, you will get a sine wave nearer to the motor requirement. So these are the two extreme advantage of lower switching frequency. But the lower switching frequency, it will oscillate the load, and indirectly you can see it's a torque pulsation also. So if you keep the lower switching frequency, the heat will be less, but you will find an oscillation at the load end many times, and this is called a torque pulsation also. So lower with the same time, you will get a lower stray loss at the motor side. So this is the both the comparison of higher switching frequency and lower switching. Higher switching frequency, we have biggest advantage is you will find a nearer to the sine wave for the motor current. The problem with this is it will generate the heat. If you keep the lower switching frequency, you will find oscillation at the load side. This is called a torque pulsation, but at the same time you will receive a low stray losses at the motor. So if you keep this switching frequency higher, let me try to explain again. If you keep the switching frequency higher, the second disadvantage of keeping the switching frequency higher is with a long run cable, you can see the switching frequency cable charge and discharge frequently. So with the higher switching frequency, the cable capacitive current will be large, and cable capacitive current will be large. If you see, the motor will supposed to this system should supposed to trip on overcurrent with a frequent current spike at the irregular interval will be observed, and it will supposed to trip the motor. At the same time, with the cable charge and discharge with the inductance, you can see the voltage ringing effect will be large. The receiving end voltage will be in terms of kV. With a high dV by dt, the motor overhand winding are may supposed to damage. So by keeping the switching frequency higher, the capacitive current will increase. Current spike at irregular interval will be observed. The motor bearing current, now the third disadvantage with a high switching frequency is if you keep the higher switching frequency, this particular motor bearing current will be increased, and the bearing life will also be reduced. So these are the comparison between keeping the lower switching frequency, torque pulsation will be there. Higher switching frequency, high dV by dt, current spike at irregular interval, motor bearing current will be increased, and many times motor will trip on overcurrent. In such type of events, what user should do? What are the learnings from this particular small session? Always follow the OEM guideline for the switching frequency settings. Don't try to alter the VSD switching frequency once commissioned. If you alter this setting, you will be trapped in another problem which we called bearing failure and overcurrent tripped and torque pulsation type of problem with the lower settings. Moderate setting like 2 to 4 kilohertz is the one of the best option. If you haven't found any vendor guideline, keep it as a 2 kilohertz, go slowly up to 4 kilohertz and leave it forever. So you will find a good result at the in between 2 to 4 kilohertz settings. Higher switching frequency greater than 4 kHz settings may damage the machine if it is not been designed to handle such a large capacitive current or bearing current. So if you cross 4 kHz, kindly read the user manual, kindly read the OEM manual, kindly read the machine manual. Otherwise, the high cost machine may damage. So this is the small presentation of IGBT switching. We will continue. Thank you. Dhanyavad.